Hello everyone and welcome to today's SQL interview preparation session brought to you by Data Science with Harivansh. In this presentation, we are going to cover two absolutely fundamental and frequently asked SQL interview questions. The first question explores the difference between two closely related SQL operators, union and union all, which are both used to combine the results of two or more select queries, but behave very differently from each other. The second question tackles one of the most conceptually important topics in SQL, the order of execution, which explains the precise sequence in which SQL processes the different clauses of a query behind the scenes. Both of these topics are asked in interviews at all levels, from fresher to senior, so understanding them thoroughly is absolutely essential. Let's get started. Let's begin with the first question. What is the difference between the union and union all operators in SQL? Both of these operators are used to combine the result sets of two or more select queries into a single unified output. This is useful when you have data spread across multiple tables or multiple queries and you want to bring all of it together into one result. However, the way they handle duplicate records is fundamentally different, and this distinction is the core of the question. Let's start with union. When you use union to combine two queries, SQL takes all the rows returned by both queries and then performs an additional step. It scans through the combined results and automatically removes any duplicate rows, ensuring that every row in the final output is unique. So if the same row appears in both the first query's result and the second query's result, union will include it only once in the final output. This duplication process makes union very useful when you want clean, non-repetitive results. For example, when combining customer list from two different branches of a business and you want to ensure that customers who appear in both lists are not are not counted twice. However, this deduplication comes at a cost. SQL must perform additional processing to compare rows and eliminate duplicates, which makes union slower in terms of query execution time, especially when working with large data sets. Now let's talk about union all. Union all also combines the results of two or more select queries into a single output. But with one critical difference, it does not remove duplicates. Whatever rows are returned by each individual query are included in the final result exactly as they are, even if the same row appears multiple times across the different queries. This means if a record exists in both the first query and the second query, it will appear twice in the output of union all. Because union all skips the deduplication step entirely, it is significantly faster than union and requires less computational overhead. Union all is the preferred choice whenever you know that your data does not contain duplicates, or when duplicates are acceptable and even expected. For example, when appending monthly transaction records from separate tables where each month's data is distinct. To summarize the key difference in the simplest possible terms, union gives you unique results. It merges two result sets and removes all duplicate rows but takes more time to process. Union all gives you all results including duplicates. It merges two result sets without any filtering, making it faster and more lightweight. As a general best practice in SQL, if you are certain there are no duplicates or if duplicates are acceptable in your output, always prefer union all over union because the performance difference can be very significant on large tables. Only use union when you specifically need guaranteed uniqueness in your combined results. One important technical requirement that both union and union all share is that the select queries being combined must have the same number of columns and the corresponding columns must have compatible data types. If these conditions are not met, SQL will throw an error and the query will not execute. Excellent. Now let's move on to our second question, which is one of the most intellectually important SQL concepts you can know. What is the order of operations in SQL? This is a question that many developers, even experienced ones, get wrong or are unsure about because the order in which you write a SQL query is very different from the order in which SQL actually executes it internally. Understanding the execution order helps you write better, more optimized queries and also helps you debug errors and understand unexpected query results. Let's walk through all 8 steps of SQL's execution order clearly. Order of operations in SQL. Here is the critical insight that every SQL developer must internalize when you look at a SQL query. You read it starting with select at the top, but SQL does not execute it in that order. SQL processes that clauses of query in a very specific internal sequence that is completely different from the writing order. Let's go through all 8 steps of this execution sequence one by one. The first step that SQL executes in the from clause. Before SQL can do anything else, before it can filter, group, sort or select, it must first identify which table or tables it is going to work with. The from clause tells SQL exactly where the data lives. It is the very foundation of every query. SQL goes to the specified table, loads all of its rows into memory, and makes them available for all subsequent processing steps. The second step is join. If your query involves multiple tables, which is very common in relational databases, SQL processes the join conditions immediately after identifying the base table from the from clause. The join combines rows from multiple tables based on the specified join condition, creating a larger merged dataset that contains columns from all the joined tables. This merged result set then becomes the input for all the remaining steps. The third step is the where clause. Once SQL has the full data set, either from a single table or from the joint combination of multiple tables, it applies the where conditions to filter out rows that do not meet the specified criteria. Only the rows that satisfy the where condition pass through to the next step. This is why the where clause is so effective at improving query performance. By filtering rows early in the process, it reduces the volume of data that needs to be processed in all the subsequent steps. The fourth step is group by. After filtering, if your query contains a group by clause, SQL takes the remaining rows and groups them together based on the values in the specified column or columns. All rows that share the same value in the group by column are placed into the same group. This step is what enables aggregate functions like sum, count, average, minimum and max to be calculated per group rather than across the entire dataset. The fifth step is the having clause. Having works similarly to where it filters out results based on a condition, but it operates at a different stage. While where filters individual rows before grouping, having filters the groups that were created in the previous group by step. This is why having is the only place where you can use aggregate functions in a filter condition. For example, having count all is greater than 5 because by this point in the execution, the grouping and aggregation have already been computed. The sixth step is select. It is a misconception that select runs first because it appears first in the return query. In reality, select is processed sixth only after the data has been sourced, joined, filtered, grouped, and having filtered. At this step, SQL evaluates the expressions in the select clause, calculates any derived columns or aliases, and determines exactly which columns and computed values will appear in the final output. This is also why you cannot use a column alias defined in select within a where clause, because where is processed before select, so the alias does not yet exist at the time where runs. The seventh step is order by. After the final result set has been determined by the select step, SQL sorts the rows according to the column or columns specified in the order by clause in either ascending or descending order. Sorting is done at this late stage because there is no point in sorting data that might later be filtered out or changed by earlier steps. The eighth and final step is limit, also known as top in some database systems. This is the very last thing SQL does before returning the results to you. Limit restricts the number of rows in the final output to the specified count. For example, a limit 10 means only the first 10 rows of the sorted, fully processed result set are returned. Because limit operates last, it always works on the final, correctly sorted and filtered data. To bring this all together with a simple mental model, think of SQL execution as a data pipeline. You first identify where your data comes from to join. Then you clean and filter it where. Then you organize it into groups, group Y to having. Then you decide what to show, select, then you sort it order by, and finally you limit how many rows to return limit. Every step feeds into the next, and each step only works on the data that survived the previous step. The key takeaway from this slide is this: understanding SQL's execution order is not just the is not just theoretical knowledge. It has direct practical implications for how you write queries, how you debug unexpected results, and how you optimize query performance. Whenever you encounter a confusing query result or an error like column alias not recognized in where clause, the answer almost always lies in understanding the execution order. Internalize these 8 steps and your SQL skills will immediately become sharper, more reliable, and more professional. Thank you.